So the first things you need to know is you have to know the area of a washer. And basically a washer is just a circle that has a smaller circle taken out of the inside. So when we're doing the area, we're just starting with the area of the outer circle and then taking away the area of the inner circle. So if the outer circle has radius capital R, pi r squared is the area. Then we're subtracting if the inner circle has a radius little r, pi r squared right here, little r squared. If you want, you can factor out a pi and write it like that. Do not, however, no, you cannot write this capital R minus little r quantity squared. That would be different. We'd have to use the box and we would have some other terms in there, not just these two. So this is as far as you can simplify it. You don't have to, but you can if you want. So the second thing you have to be able to do is to be able to find the volume of a hollow cylinder. So that's really what we're working with this time around. And it's the same idea. Area of the base, exact same thing as we did up here. The big radius squared times pi minus the little radius squared times pi, and then times this width or height, or whatever you want to call it. So today we're working with volume of solids of rotation. And the second part of that. So let me give you a sample problem and then we'll see what's going on. Find the volume of the solid formed by rotating the area bounded by the line y equals 3x, the x-axis, and the line x equals 1 around the line y equals -1. So first things first, I'm going to draw that out. I'm going to do my axes in pencil because we're going to have a lot of little lines going along here. So here are my axes. I've got one line, y equals 3x. I've got one line on the x-axis, that's y equals 0. One line, x equals 1. And then I've got an axis here at y equals -1. So I'm going to do that nice and dark. There's the axis I'm rotating around. Now notice that the area we're interested in is this area right here. And we're still going to draw a rectangle only inside that area. It's going to be perpendicular to that y axis, it's going to be perpendicular to this axis that we're rotating around. But the thing to notice is that what's happening now is that in the previous problems, this axis was touching the area in question, and now it's not. There's this gap right here. And so I've got another couple little pictures showing you what this looks like here. So what happens is basically that we have two different curves. We take a chunk of it, and we're going to rotate it around like that. But notice right here that this is creating a cross-section that isn't a full circle. It's one of these hollowed out circles that we were working with earlier. It's called a washer. And what that changes is simply that we're going to be using these formulas up here in order to find the area of the cross section rather than the areas that or the formulas for area that we were using earlier. We can do the same thing if we're going around the y-axis. It's also the same idea if we're going around a line y equals or a line x equals, like we are in this problem here. So when I look at what I would get for this sort of a problem, basically I'd get some shape that looks very similar to the one that we saw in the video, where there's this missing part right here, and it forms a washer for the cross section. And so in order to find the area of the base, all I'm going to have to do is use little formulas up top. So to find the big R, what I'm looking at is I'm just looking at the distance from the axis up to the very tip top function that I'm working with. That's going to be my big R. And then I'm going to take away the piece that's making up the radius in between the axis and the bottom function. So why don't I go ahead and now set up the usual parts that we do up here with this. I'm still using this volume from start to stop, area of base times width. But what's changed is that this area of base, I'm going to be using the pi big R squared minus the pi little r squared. Instead of labeling this height, I'm still seeing that this is going to be a dx, so when I'm doing my volume, I can do dx. I can see that since it's x, I'm going to be going here from where x equals 0 up to where x equals 1. But now, what I'm going to do is I'm going to extend this line down to touch the axis. This is going to be my big R. And it's going to equal not the top line minus the bottom line for the purple area, but the top line minus the axis. Notice that these can all be written as f of x, so f of x equals 3x, f of let's call it g of x equals -1 for the axis. So r is simply going to be this top function minus the axis, right like that. Now I'm going to need my little r, so I'm going to go ahead, I'm just going to put this here, that's this distance right here. The radius of the circle that we're going to take out, so we have a hollow cylinder. So little r is still going to be whatever's on top of the rectangle minus whatever's on the bottom, but in this case, let's label this h of x equals 0. Our top function is just 0 minus our bottom one, which is -1. So little r equals +1, big R equals 3x plus 1. Coming back over here, all I'm going to do is I'm going to put it into my formula for area of the base. So I've got pi big R squared, that's 3x plus 1 squared, minus pi little r squared, all of that, times quote-unquote dx. Just as we did before, I can plug this into the calculator. Pi times 3x plus 1 squared minus pi times 1 squared, which is just plain old 1, comma x, comma 0, comma 1. And there we go. So let's go ahead and write down the steps. For this, it's only slightly different than what we've done before. That says steps. First of all, we're going to draw the area and mark a rectangle perpendicular to the axis. Second, we're going to set up our start, stop, and dx or dy. Third, we're going to, and this is the new step, we're going to extend the rectangle to the axis to form big R, and draw a second rectangle for the radius of the circle to take away. So that's the little r. Finally, we'll write the expressions for r and r and set up the answer. So let's take a look at a couple more problems. This is problem 2. Find the volume of the solid created by rotating the area in the first quadrant bounded by y equals x and y equals x squared around the x-axis. Okay, first things first is always to draw the area in question. So just in this first quadrant here, so I've just got y equals x. This one is y equals x squared. We are rotating around the x-axis, so here is our axis. That means we're looking at this area right here. We have to draw a rectangle perpendicular. That means this is going to be a dx, so I can start setting up. We've done this a whole bunch of times, so you might know this already. Let's convert these to f of x and g of x first. F of x, g of x. So that means x equals x squared. 0 equals x squared minus x. We've done this a bunch of times. X minus 1. 0 equals x. 0 equals x equals 1. Those are our two bounds. So we're going from 0 to 1, and our equation we want to find the area of the base. We notice that we're rotating this around this axis, meaning that there's a gap. At least for this part, it narrows down here, but for anywhere there's a gap, that means we have to use this formula. So we want our big radius, which we're just going to extend down. And then we're going to take away the little radius that's right there. And incidentally, if we were going to draw this, what it looked like once we rotated it all the way around, basically what it would look like, here's our axis, here's our shape. It would kind of look something like that if we rotated it. At any rate, our big R right here is going to be this top function, which is x minus the x-axis, which is 0. And this little r is going to be this function right here, which we see as g of x equals x squared minus the axis, which is 0. So when we come to do our equation, we're doing pi big R squared minus pi little r squared. So pi big R squared is just x minus pi times little r squared. X squared squared. And when we put that into the calculator, pi x squared minus pi x squared squared, or x to the fourth, comma x, comma 0, comma 1, 0.419. And there we go. Similar things happen if we're rotating around an axis that is above the area in question. So here's our third problem. Find the volume of the solid created by rotating the area bounded by, and it's going to be the same as we were working with before, y equals x squared, oh, maybe not quite the same, and y equals 2x, around the line y equals 5. Y equals x squared is right there. Y equals 2x. Y equals x squared. But our axis is going to be up here. Y equals 5. So we've still got the same thing. Our area is this piece right here. We're going to draw our rectangle perpendicular, so that means we've got a dx. Actually, I'm not going to put that down there because I'm going to be writing more down there. Let's put that up here. So that means I can start setting up my equation. We definitely have a dx. That means everything needs to be in terms of x. So this is f of x. This is g of x. This is h of x. I can see that my starting point is going to be 0. Once again, we can set these equal to each other. X squared equals 2x. In order to figure out what the bounds are, x squared minus 2x equals 0, x minus 2 equals 0, x equals 0, x equals 2. So that means I'm going from here where x equals 0 up to here where x equals 2. And now area of the base, since what's happening is that I'm rotating this around this axis up here. There's a big gap here. So that means I'm going to have to use pi big R squared minus pi little r squared. And for those of you who like your graphs, I'm just going to do a quick sketch of what this is going to look like. So basically I'm saying we're rotating this area around here. It's basically going to be kind of a curvy sort of cone shape. Okay, so to get my big R, I'm going to extend this to the axis. Now if the axis is above, that's okay. Same idea as if the axis were below. So it actually looks like I really should have written my dx on the other side. I was right the first time. I'll put it over there now just so that it's not in the way. So this one, basically this longer radius, that's going to be my r. Big R is always going to be bigger than little r. So this is capital R. And it's going to be the top function, which is 5, minus the bottom function, which is x squared. And then I'm going to take out the circle with the radius little r. And it's okay that this one is touching the top function, whereas in the previous problem, big R touched the top function. Basically, whichever of these lines is longer, that's big R. Whichever of these lines is shorter, that's little r. So little r is also going from 5 on the top. We're going to take away whatever this is. That looks like 2x. So there's my little r. Now I can put that into my equation. Pi big R squared, which is 5 minus x squared squared, minus pi little r squared, 5 minus 2x squared, all of that dx. Once again, fun with calculator. Pi 5 minus x squared squared minus pi 5 minus 2x squared x comma 0 comma 2. Make sure you have 3 places after the decimal for the AP test. And that's pretty much what we're doing.